Okay, we are back with our graphing of sine and cosine functions. All right, so we just finished up. This is a sine curve. So it's the parent function. So anything that is a sine equation is going to be based off of this shape. Okay, let's look and see what cosine does. Same thing. We can go to our calculator and, hold on, calculator. Okay, and we can graph a cosine function. So go down here, enter, graph. Okay, here's a cosine curve, which looks very similar to the sine curve. And really, if you just shift this graph over, you can make it match a sine curve function. Okay, so the difference, actually, let's go back and turn on the sine so you can see them one on top of each other. Okay, so you'll notice the blue one is your sine curve. It starts at 0. Okay, so I'm just starting at the origin. It starts at 0. Whereas on the cosine curve, I'm going to use my up arrow. We'll jump to my cosine equation for me. You can see that cosine starts at 1. Okay, but they have that same shape. It's that wave. Okay. All right. So we could do the same thing that we did with the sine equation as far as plotting points. Okay, so I'll do just a couple of those just to give you a feel. We won't go through the whole rotation though. Okay, so if we kind of do the same thing, x and then y equals cosine of x. So again, if we start at 0, I'm using the same scale. So this is going to be pi over 4. This is going to be 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay. All right. So at 0, if you look at your unit circle, 0, the ordered pair is 1, 0. Okay. Well, how do you find the cosine? The cosine is always the x value. So your cosine is going to be 1 at 0. Again, I'm going to use, that is going to be my 1. Okay, pi over 4. Well, look at the x coordinate. It's root 2 over 2. So about that 0.7 again. Okay, at pi over 2, okay, you're up at 90 degrees now. The x value is 0. At 3 pi over 4, you have a negative root 2 over 2. So down here, again, just estimate about a negative 0.7. Okay, at pi, the x value is a negative 1. At 5 pi over 4, your x coordinate is a negative root 2 over 2. So about a negative 0.7. 3 pi over 2, you are back to 0. And then 7 pi over 4, you are at root 2 over 2. And at 2 pi, you are back to 1. Okay, so your cosine curve looks like that. Okay, and again, once I see one section of it, I can just mimic that same pattern going the other direction. Okay, so notice that we started at 0, was at 1, and that at 2 pi, we finished back up at 1. Okay, so that is just going to repeat. So you can use that going to the left. So if I know I start at 1 at 0, I'm going to do my little curve. It's going to do something like this, and then it's going to end up back up here at 1. Again, you can do your unit circle. You can go the other direction around. So you've got your negative values. But if you kind of understand the shape of the cosine, your high point, your maximum value is at 1. Your low point is going to be at negative 1. Okay, so if my high points are at 1, it's all very symmetrical. So then my low point is going to be at negative pi, negative 1. I will be crossing the x-axis at negative pi over 2 and 3 pi over 2. So actually, my little dotted end didn't do too bad of a job. Again, I know what the curve looks like, so I can just follow that shape. If you want more exact, you certainly can do a table, plot more points. All right, so that is what a cosine function looks like. All right, now, as we always do. Okay, so there's the parent function, but what happens if? What happens if I put a 2 in here? What happens if I put a negative in here? How is that going to affect my graph? Okay, so for this one, y equals 2 sine x. And then you'll notice number 4, y equals sine 2x. So is there a difference with the 2 being out front? And a difference with the 2 just being like the coefficient of that x? How does that change things? All right, well, it does make a difference, and I'll show you how. Let's just do a couple of points again and try to show you what happens. So x is going to be my angle measure. Again, I'm counting by units, increments of pi over 4. Okay, so y equals 2 sine x. Okay, so 2 times the sine of 0. Okay, well, sine of 0 is 0. So 2 times 0 would just be a 0. Okay, pi over 4. Well, sine, so it's 2 times the sine of pi over 4. Well, sine of pi over 4 is root 2 over 2. So I'm going to go 2 times root 2 over 2. Okay, my 2's would simplify out. I get about a root 2. Okay, pi over 2. The sine is 1. Okay, so it'd be 2 times the sine of pi over 2. Well, that would be 2 times 1, or that would be 2. Okay, 3 pi over 4. So 2 times the sine of 3 pi over 4. So that's going to be 2 times root 2 over 2, or you're going to end up with root 2 again. Okay, let's do pi. So 2 times the sine of pi. So sine of pi is 0. So 2 times 0, that's going to be a 0. All right, let's plot these first 2 points and see if you can tell what is happening. Okay, so 0 is at 0. Root 2. As a decimal, root 2 is approximately 1.414. So just shy of 1.5. Okay, so this is my 1. This would be my 2. So at pi over 4, which is right here, I'm going to do just under 1.5. Okay, at pi over 2, we're up at 2. At 3 pi over 4, we are at root 2 again, so just under 1.5. And at pi, we're at 0. Okay, so my first part of my curve is looking like this. Okay, let's look at your calculator for a minute and see what we have going on. All right, so let's go back to y equals. I'm going to keep the sine of x, and let me see. Do I have, oh, I guess I don't have this equation, do I? 2 sine x. So 2 sine of x, and I can graph it. Okay, so my original is going to be blue, and this 2 sine x is going to be in orange. Okay, So there's that blue one. That's my original sine of x. Okay, so the maximum was 1. Well, when we put a 2 in front of this, it got multiplied by 2. So now my maximum is at 2. Well, what do you think is going to happen if we go down? Okay, so my next portion is going to come down. Well, you can see I go all the way down to -2. So -1 here, -2. So you can use that. I'm at 3 pi over 2. You can check it. You can keep doing the table if you want to, or you could do a zoom and trace, and you could type in, well, we can do that. Trace. So if I go, let me see, what do I want? I want to do 3 pi divided by 2. 3 pi divided by 2. Oh, I'm on the wrong curve. Go down. There it is. 3 pi divided by 2. I'm down at -2. Okay, so then at 2 pi, I meet again at 0. So this is going to get sketched in. And there it is. Okay, I can do the same thing going the other direction. I'm going to cross at -pi. I'm going to come back to the x-axis at -2 pi. So if I just, again, visually, just shift that over. So I'm going to go down low, come back up, and I'm going to go high here at -3 over 2. So I'm going to come up, get that, and there you go. Okay. All right, so putting that 2 in front is going to make that graph taller. Okay, for lack of a better word, it's actually called the amplitude, which we'll talk about more. Okay, now this one, sine of 2x. Okay, let's just go to our calculator. Okay, let's undo this one. Let's go sine 2x, and let's graph it and see what happens. So there's my original one. Okay, so the red one is the sine 2x. So you can see what happens is the height is the same. Okay, the high point is a 1, the low point's a -1. But what it's done is it's been kind of squished horizontally. Okay, so whereas with the original sine function with the blue curve, you need a distance of 2 pi to see one complete wave of this curve. Well, with the red one, since it's gotten squished in, look at how much you need to see to see that whole thing. So it's going to be, so our curve goes up. Oh, I'm on my wrong one. There we go. Goes up, comes down, comes back up, and about right there completes one section of this sine curve. And if you'll notice, you're at pi. Okay, so for this curve, we're going to start at 0 again. It ends at pi. Okay, so if it starts at 0, ends at pi, it crosses halfway through, it's going to cross at pi over 2. Okay, then the height is 1. So at halfway, in the middle of 0 and pi over 2 is pi over 4. That's going to be its high point at pi over 4, and the low point at 3 pi over 4. Okay, so you can kind of see that. Now, again, we can go to a table, we can make a lot of points, but once you have the overall feel of what this curve looks like, just use that same pattern and then just adjust what you know. Okay, and then you can do the same thing again. Okay, your next curve is going to come up, it's going to go down, come up, go down. There's your next piece of it, and you can go to the left. Okay, all right, we're going to stop there for the moment, and stay tuned. We'll be back with more